everyone. Ooh, I changed my screen. So hi, everyone. My name is Christina, and I am going to talk to you today a little bit about version control and Git. So, so who are we and why are we here? It's a good start. So basically, my name is Christina.
Are you sharing your screen by chance?
I'm sharing my screen in my head. Does that make sense?
Well, unfortunately, we won't be able to see it, but we can see it now. Perfect. Sorry.
Perfect.
Back to you.
Okay. So, yes, today we're going to talk about version control and Git with RStudio. If those things don't sound interesting to you, then you don't have to be here. You know, if this doesn't sound right, you might not be in the right place. But so today we're going to talk about that. Now, who are we and what are we talking about? Why are we talking about it, really? So my name is Christina Fillmore. I'm a data scientist here at GSK. So I work a lot on kind of building out solutions for my pharmaceutical colleagues in biostatistics. I also am very involved in PSI, which is the pharmaceutical stats industry group within kind of generally Europe, although primarily the UK and some other places. And as part of that group, I am part of the R group called AIMS, and I co-run with Lynn something called KGaA, which is a project for comparing statistical results in different softwares. And so comparing systems, whatever. And so in doing that, we have a Git repo that is for that. And part of that, developing that Git repo and doing that, we realized how much there was a need for doing kind of a basic Git training, which is how we came to be today. So that's the long story short of that. So that's who I am. Now, Lynn, do you want to introduce yourself as well?
Yep, sure. So I'm Lynn Taylor. I'm a statistician at Paraxel. I worked on the R Validation Hub project for I think around like sort of 6 years or so, and got really involved with R in pharma and how we can encourage the use of R within the pharmaceutical industries and how problems like validation can be overcome. And then, like Christina said, I've then become more recently involved with a Fuse project called KGaA, which is comparing analysis method implementations in software. And through that, we need to collaborate together. And that's why we've ended up looking at collaborations, repositories, and that requires Git version control. And I've found that with my background in statistics, I've never actually been taught Git or the sort of way that Git works differently to other version control that I've been used to in the past. So that's how this has kind of come across, and hopefully you'll all enjoy it today. Alex, do you want to go next?
Sure. So my name is Alexandra Lauer. I go by my short name, Alex. So please feel free to do that as well. Yeah, I am a biostatistical analyst at Merck KGaA, and I attended PSI conference this year where I met Lynn and Christina. And from my background, I am a member of the R Tables for Regulatory Submission working group, and I'm also a biostatistical analyst. So Tables, my working group participation, that kind of led me to version control. And as kind of that third part of my profession, I'm also co-leading the R user group at Merck, together with a colleague. So I encountered the problem that a lot of times biostatisticians or statistical programmers are not familiar with version control. Whenever I pushed a project to them and said, hey, have you tried out that package? They came across an issue and were like, okay, this and that is not implemented. And they were simply not aware of what to do when I said, hey, have you tried open up an issue? So all of that kind of resonated with Lynn and Christina when we met at the conference. And yeah, we're now super excited to present this workshop with you, and I hope you like it. Irene, please.
Hello and welcome. So my name is Irene, and I am a senior statistician at Incyte. I'm mainly work on clinical trial, but a lot of my work is also focused on helping the transition to start to really use R for clinical development and clinical submission. and I love Git, so I actually really hope you will enjoy this workshop. It was quick.
Perfect. So with that, let's get into it. Enough. That's why we're here, basically. We all love Git. We all know why we like it. So we're here to teach you to love it, maybe a little bit as well. So how this is going to work is we're going to have a short little intro, and then this is basically going to be kind of the tale of two halves. The first half is all going to be in theory. This is going to be not necessarily using Git directly, but building that foundation. There are a lot of exercises, both for the theory part and the practical part. So this is very interactive. We would love you to take part and be interactive. As Phil said, please do use the chat box to ask for questions. And also, kind of the only other thing is, as we do the exercises, once you finish an exercise, do raise your hand. I'll remind you every time, but just in case I forget to remind you, there's my first reminder. So with that, and one final thing, the final thing is our environments. As Phil said, we are using Posit Cloud today. So you can use Posit Cloud for the practical exercises. We're doing this primarily because Git is already installed on Posit, which is very convenient for us when trying to explain to you how to use a system that we know is already installed in. The other thing we're doing is we are using a Shiny app for all of the theoretical exercises. So Lynn is going to put that in the chat box, I think. She's done it. And so basically, we're going to go through this app for every exercise, for all of our theoretical exercises, in order to give you an example, give you a chance to kind of get used to using Git and understanding how things are happening behind the scenes. Okay, so what is Git? Why are we here today? So Git is a version control system. You may have heard of it, that like described that way. It works kind of as you'd expect. It helps you track your versions, but it's a little bit unique. So it was created by Linus Torvald, who help him make Linux. So the guy who made Linux needed to have some way of tracking all those versions as he was making it. And the traditional version control systems of just checking one thing in and checking one thing out and having things super, super linear just weren't cutting it for him. So he needed something slightly fancier. So he made this, which is a really great system. Now, you probably have also heard things like GitHub or GitLab or maybe even Bitbucket. All of these things are not quite Git, but are very similar. The difference is basically that Git is going to be on your computer. It's going to be running locally. That's what's going to track the versions. Whereas GitHub, et cetera, are in the cloud service-based systems that help you manage these Git repositories so that you can share them with your friends and colleagues, etc. Because stuff on your computer needs to get out into the world. How it gets out into the world is going to be things like GitHub. So for this workshop today, we are going to be using GitHub, but most of what we're teaching you is pretty agnostic to any system. And generally you can switch it out for GitLab, which I think is the biggest one I hear about as an alternative, but I know that some companies also use Bitbucket. So let's get down some basics. Basic terminology when we think of kind of Git. The most basic one is going to be a repository. So you'll hear people call it a repo as well. But basically, it's the collection of code you want to track together. This is going to be a folder. It's just a folder on your computer, and anything you want to track together is going to live in that folder. So it's made special by like having a secret little Git folder in there, in your folder that helps track everything. But basically, when you put things in a repo, you want to group things together that you want to track together. So things like if you're doing a study, you maybe want to put all your study code in a single repo, or maybe you're writing up a paper for submission and you want to put all of that in a single repo. Just how you would normally do your kind of project management. Things that should go together should stay together. Things that go together in a repo will be tracked together. So the next thing to talk about is a commit. So a commit is the saved version of your folders, of your files, or what's in your project. So there are a couple of things that make commits a little bit unique compared to maybe a check-in, check-out, or like a snapshotting system. First of all, it tracks changes. So rather than tracking the whole file every time, it's only looking at the changes from what happened last time to this time. This makes it pretty efficient in terms of how the file storage, but it also allows us to do some fun things, which we'll talk about later. But basically, it's only looking at the changes, the line-by-line changes you've done in your file. The next thing that makes commits a bit unique is you can commit multiple files into a single commit. Let's just say that you created a variable and you accidentally spelled it wrong, except for you put that variable in 5 different files. Well, what you can do is you can just go through and change the variable everywhere and change it in all the files and have one commit and be like, I forgot how to spell. And then you can change it and put them all together. But sometimes when you're making commits, you want to group things together into a single commit because, you know, you're all doing the same thing. So those are some kind of the basics of doing that. Now that we have some really basic understanding of things that are happening in Git, let's go to a case study. Sometimes it's easiest to learn about the stuff with the reason why you might want to learn it. So today, throughout the workshop, we're going to use the case study of Camille. Camille here is our lovely statistician. She got to, start her week. She had a coffee, she had a laptop ready. She was excited because this week is the week she's putting things out for publication. So she starts doing some analysis and she makes some graphs. That's what happens Monday. Tuesday comes along. She then submits to Journal A. She's having a great time. She's like, you know what? Actually, Journal B is probably a good idea too. So she does more analysis, makes some more graphs, does all the changes she needs to do because not all journals have the same publication standards. So does some more changes into her graphs in order to submit to Journal B. Then it's Friday. She submits to Journal B, has a great week, shuts down her computer and enjoys her weekend. Unfortunately, she comes back on a Monday morning to the unfortunate email from Journal A being like, we have some questions and we would like you to make some changes. Well, that does not help her mood. She needs to change her code, but she's actually already changed it so much from when she submitted it to Journal A. So she's going to have to go back. She has to find it. She has to figure out where she stored it. And also she doesn't want to undo all of the work she's done for Journal B. So what's she going to do? Well, before we get into solving her problem, we're going to make you do an exercise. So the first exercise is actually about committing. And so
Christina, let me just interrupt 1 minute before we explain the exercise. The Shiny app is now got a 503 service unavailable.
Oh no.
Yeah. And I tried it, but it's not come back up. So
okay,
I think if you refresh the page, it's working okay for me. It happened at first and then I just refreshed it once or twice and then it came back. So you might
so maybe if you shut your browser, it's still doing it for me.
It's working for me. Who knows?
Oh, when I refresh it.
There
it's back. Welcome back.
Okay, sorry, Christina. I just wanted, everyone was panicking and I was like, it's not back for me yet, but I'll keep trying. Okay.
It's probably because we're all refreshing the page repeatedly.
Probably.
So if you want to go back to the slide, sorry to interrupt.
No, it's fine. We're going to come here. You should be on this thing that says committing. It should look like this. If it's not pink, it's probably not in the right place. But what you're going to do is you're going to work through question 1, 2, and 3 here. Each question has like an explanation of what you should be doing. So what you're going to do is we're going to have 10 minutes. So I guess that's almost, I can do 3:28 my time, which 28 past, whatever that is to wherever you are. And then we will resume. So if you have any questions, just go into the chat. Feel free to ask. And again, remember, please do raise your hand when you are done. New emojis.
Oh, that's funny. Okay. Well, I will slowly fade into the background and let me know if you need me. Yep.
No, that's great.
Oh, we're getting a bunch of thumbs up in. So cool.
Okay.
Wonderful.
So I'm just going to work through the exercise. It might feel weird doing exercise so far early in the day, but it's nice to learn in a hands-on way, particularly with Git, because I think if you just see things in slides, it makes sense. But then when you come to do it, the terminology and things can get confusing. So hopefully you find this a really hands-on experience to help get some of the terminology into your mind so that when you see this in the future and we're not here, you'll know what you're doing. So we're starting really basic. We're going to do a first commit. And you need to change the code in some way. So I'm just going to replace the my name with my name. And I'm going to put a commit message. So I'm just going to say personalized. Oops, I'm going to spell it right. Personalized the print and click commit. And immediately we see that the diagram has changed. So we've got the first commit here, and then we've got one with a personalize the print. So that's it for the first exercise. If there's any questions, I'll try and watch the chat as well in case anything comes up that you want me to go over again. And then question 2. So this is just practicing making commits. So if you hover over these dots, you'll see this one is my first commit, this one's my next commit, and this is my final commit. And we're going to try and replicate this network diagram. So first of all, my first commit, and I press commit, and I've got my first commit made. So for the second one, this is my next commit, and I hit it again. And again, you can hover over these, it shows you the commit messages, and you can see that that's creating the same as this one. And finally, the final commit. And hopefully you got this message saying you've matched the network graph. Now, if you've typed something different in as the commits, you won't get that message, but that's fine. You can still move on to question 3 if you understand what we're doing. It's very basic, but we're at the start of the course and things will get a bit more complex. Also gives you good practice on getting used to our diagrams and how some of the questions work. So going on to question 3, this is Camille. And as Christina mentioned in the slides, you can click over each one of her commits in this network diagram. The first one, she was exploring the blood pressure data. She got this graph. The second one, she cleaned up the plot for journal A. That was using this graph. And in the third one, she started looking into journal B and changed the graph to be like this with splines on. And then finally, she made a fourth commit and she changed the colors and tidied up the graph for journal B. So what we want to do is to find the right one that's journal A, because she's been requested from the journal to make changes. And unfortunately, the version of the code she's looking at is this one now, which isn't the one that she wants to make edits to, because it's very different to the one she submitted at journal A. So we need to find the right one, and we can look at the text that's been added in. It's a helpful text. It would be even more helpful if her commit messages actually said what the changes she'd done to the program was, because at the moment she's just gone version 1, version 2, version 3, and version 4, and that's making it very hard for me to find which is the version that I want to use. And to make this easier, you can do something called a tag. And so when I find this one, which says the last reference to journal A in it, I can now click tag, and that will ask me to add a tag message, which I'm going to put as journal A final version, which is a much more useful commit message that I'll be able to find this in future. And I submit that, and now this is tagged with hopefully a more findable commit message, so that I can do that in future. So Christina, did you want to share again, and we'll go back to the slides and just check for any new comments?
Yes.
Trying to find where to give you the sharing back.
Wonderful. So,
oh,
great.
Do you want me to just talk through this one?
Which one?
This slide.
Question?
Yeah,
Yes,
I just
slide.
realized. We have one more slide. So just to look at it graphically on this last slide, we made a commit, and this is starting a network graph. And we saw the 4 commits as there was each of those graphs that were done. And then we identified which one was the one that she wanted to send to the journal. So we've checked out each of these different commits by clicking on each one, and that changed the code that you could see when you checked out those different commits. And then we've tagged it, and then we've put a commit message in there just so we can find it in future. So yeah, I think that's the end of that exercise.
Yeah. So yeah, There we go. So I made you do a bunch of things that you probably had never done before while doing that. So let's go back and explain a little bit of the things that we did in the exercise. So the first thing we're going to talk about is checking out. So checking out is just a command in Git used to move around. You can think of wherever you're checked out as like where you are currently located in space on these graphs that we're showing. So where each graph, each dot represents a single commit. We're using these network graphs because they're pretty commonly seen throughout using Git. So it's just kind of what's around. So the commit that you're currently on is referred to as the head. That's just kind of the nomenclature. We're trying to avoid as much jargon as possible, but that is jargon that you'll run into if you don't know much about it. So there's that one. There's still a lot of hands up. If you're done with the exercise, great, you can put your hand down. If you have a real question, can you put the question in the chat? And if not, none of those things, cool. I'm seeing hands go down. That's good. Okay, sorry. Anyway, so that's what checking out is. So checking out is just where you are in space as you move around from place to place. You need to check out the new place and then you go to the new place. And that is the process in GitHub of moving around from your different commits. The other thing we talked a little bit about was tagging. So tagging can be super useful for identifying things. In this case, identifying the plot that was used for Journal A. So now Camille knows where that location is, which is super helpful for her, but she actually does need to do some updates. So there's going to be a slight problem because a tag is associated with a commit. It can be on any commit, but it is the commit that's tagged. And so it can only be that one commit. In this case, we need to do updates, right? Journal A asked Camille to do some updates. So in order to do those updates, she's going to have to use something other than just a tag to identify it, which is really helpful, but it's not quite enough. So in this case, we're going to need to use a different thing called a branch. So branching, how it works is in Git, by kind of standard, we use our kind of primary branch is called main. This is where everything typically is coming off of, but you can branch off anything. But this branching allows us to make nonlinear changes to code. So rather than having to just check something in and check it back out and check it in kind of a more linear version control system, we're allowed to kind of make changes from wherever we want to do it. So by making changes, what we're going to do is we're going to find a commit that we want to, and then we're going to branch off of that commit. So in this case, we've made branch 1, and now we're going to add some changes to branch 1. Now, these changes on branch 1 are not going to be on main branch. So in the case of Camille, the updates that she made to journal B is not going to be for journal B. They won't be affected by the changes that she's making to stuff for journal A. They're kind of now entirely separate. They're swimming in their own swim lanes, if you want to use the swim lane analogy, or they're like branches on a tree. They're maybe from the same source, but they live in different spaces. So you can have as many branches as you want. So if, for instance, maybe she wanted to do another update later on with something earlier, she could make branch 2. You can have as many or as few commits on any given branch, and there's no limit to the number of branches that you can have or the number of commits that can have branches off of them. So if she wanted to make multiple branches from the same commit, that would be fine. There's really not a lot of rules when it comes to branching. You're allowed to do basically whatever you want. So with that being said, now it's time to go back to the app. So however you chose to be in the app, whether through How's It Connect or through the app, through the URL, we are now going to change over from being, see if it will open up for me, maybe, let's see if it will reload, potentially not. We're going to go to the making branches section. So now we're going to do question 1 and question 2 of the making branches. As usual, will be available for help. So if you have a question, please put it in the chat. And when you're done, do a thumbs up sign rather than raise your hand, because now I know you can do a thumbs up. And this one will also be about 10 minutes. So 7 till. So in other words, for me, it's 53.
And just regarding the question on tags, yeah, normally you wouldn't tag every commit Your commit
No.
message should identify what you have committed. But for example, if you're just at the point where something's being sent to a journal, it might be useful to add a tag to that to help you locate it later on, because you're going to end up with loads and loads of commits. So hopefully that answers that question.
Yeah, you'll also see them, the place you're going to most often see them, or at least I feel like I most often see them, but I'm entirely jaded by what I do as a data scientist, is that I see it on, like, when you see, you tend to tag releases of packages. So if you're using an R package, the version 1 point whatever is going to probably be a tagged release, or it probably should be a tagged release, and say that that's the tag.
The commit and you're just using the app, it's probably best just to restart that exercise. So either go out and go back in again, or yeah, reload the app. There's a question, is there commonly agreed upon a best practice language for tagging or commit messages? For example, should there be adverbs or actions, etc.?
Is just responding, but yes, typically you do probably want a verb, but the important thing is that it will make sense to you later, and it will be intuitive. So things like changed variable, probably not super helpful, because future you will not understand what variable you changed or why you did it. So there is definitely kind of a fine art to commit messages, that I don't necessarily, if not perfected by any means. You usually want them to be quite short, so you don't want them, I think it's, you get a kind of message being like, consider having it less than 80 characters, I want to say. So don't write a thesis, but like, say, you know, updated ADAE for new safety flag or something like that might be a good commit message, because you understand exactly what's changed.
Yeah, a lot of times people feel like version control is for collaboration within a larger group, but honestly, most of the stuff you do for you and your future self. Like, at least that's my experience. Like, future Alex will have no clue what Alex today did. So keep good track and make sure that the commit messages are meaningful to you.
And just to answer a couple more of the questions, you don't need to give a name to the new branch. It's just fixed as, I think, analysis 2. And when you're tagging using Git RStudio, I don't think there's any colors. No, it's just identified as a tag. The color coding in our Shiny app is just to help you see when we get to slides and things, which ones are the tagged ones, which ones are just committed. Are just committed. And I think tagging was on the commit one. You don't need to tag anything in exercise, the second exercise, making branches. Maybe I should work through the exercise. Do you think, Christina? Yep, I see notes.
Yeah.
Okay, so all we're doing is, this is the main branch. This is our network diagram. We can see my first commit, my next commit, and my final commit, like you saw in the previous example. So we're going to make a branch, and then we're going to add commits. So 2 additional commits. And if we picture ourselves being Camille and she was editing her graph, this commit at this point could be a cleaned, or maybe she wants to do something different. So like revised for journal A or something. So we can commit that, and we've branched off the main branch here. We've created a new branch, and then she's carried on working on that, and maybe she's added some color and formatting, and we could be more specific about what formatting she's done, but we add a second commit, and we're working along this branch now. And that's fine. We could carry on working along that branch, but maybe now she realizes that she's done something here that she didn't really need to do. And she thinks, oh my goodness, when was the last version I had that had code that was more similar to what I want to do now? Maybe she's explored one way of analyzing something, but it's just, you know, not what she wants to do anymore. She wants to go back to a version that is more like where she wants to go now. So she can change and she can change branch, and she can check out the main branch. So the way to do that is change from your new branch back to your main branch. And you can see this is now in bold, indicating that we're back on our main branch again. And if here she wants to go back to where she was and add changes aligned to journal B's needs, she can add that commit there. And now we're back on the main branch, and this is working on sort of maybe journal B's specifics. Now, at any point, she can still navigate back, and we call this a checkout to the new branch. And we can see here that this was actually revised for journal A. And it starts to tell you what your code's doing, whether it's working on journal A, whether it's working on journal B, you know, what you're exploring at that time, and helps you locate the version of code that you want. So a commit has been added here, and we've also got the commit on the main branch as well. So if we go to question 2, we're back in the version of finalizing things for journal B, because the bold one here is at the end. So this is the code on version 4. Again, you can check out each of these and have a look how the code changes. Just make this a bit smaller so you can see it on the screen. Maybe like that. So that's version 1 of the code, version 2 of the code. We tagged this in our first example. So we know that this is the version that was cleaned up for journal A. And so by checking out each of these committed versions, we can then do a branch from the tagged out version and commit that. It would have asked you to do a commit message if you're in the actual system, but this is just an example. And we can see that not just branching from the last version, we can actually branch from any version of the code that we've committed or tagged. And if she has more commits, she can just keep committing along here and working along the 2 sets of the branches. So should we go back to the slides, Christina?
Sure thing. I swear by the end of this, I'll actually be able to share slides in Zoom. Okay, so a quick recap of the exercise. We made it a branch, we committed to the new branch, and we've now tried checking out different branches. So checking out is where you're mostly going to use checking out in your day-to-day life is between branches. It is kind of the most common way to just go about things. So making branches is fun. We maybe have a lot of branches, but realistically, we probably want to bring back some of the changes we've made in the past. So for instance, in our main branch 1 example, potentially the things on branch 1 would be useful to us. We might want them. We probably don't want to be just making changes everywhere. It's basically like having a billion versions of the code running around, which we are trying to avoid. That's why we're using Git. So what we're going to do is combine them back together. To do that, we use the Git command called merging. So we're going to just merge things together by checking out the branch you want it to merge into. So in this case, we now see our little head has come onto main, and then we are going to merge in branch 1. So we'll say, the Git command for it is git merge branch 1 into main. So great, perfect. Most of the time, that's how it will be. It's quite easy to merge things in. There won't be a problem. But occasionally, we have conflict. Conflict is never good. We don't like conflict. But what happens with conflict is that, so Git is tracking the changes per line, right? I said that at the very beginning, the thing that makes it get a little bit unique, and what makes the commits unique, is it's tracking the changes in the file as opposed to the files themselves. So what happens when you have a merge conflict is basically in branch 1 and in main, there's there's like a single file where on the same line, there's been a change. So 2 people, 2 branches have changed the same file in the same place. And Git doesn't know how to resolve that. Fundamentally, Git is a bit dumb. Like it seems really smart. It's not. It is not going to keep track of things chronologically or anything like that. So even though, let's just say, maybe you haven't touched main for like a month and you've made all of your updates to branch 1, and you're like, why would you think Git that it should be main should be in front of this, or like this little commit bubble should happen first? It's going to go like, I don't know. I'm not making decisions here. So it needs to know how to resolve these things. So when you do get a conflict, what will happen is it will complain at you saying, whatever file has a conflict in it, fix it, please. And in that file, you'll end up with something that looks like this. You'll have kind of 3 special lines that have been added in. The less than sign, which then usually says head, although sometimes it might say main, the equals line, and then the greater than sign. So on the less than sign, is it saying it's just telling you the branch that you were on, or whether you're at head. So basically, as I said before, where you're currently located is usually called head. So it's going to say, head, everything between that line where it says head and the equal sign comes from that one branch. Everything from the equal signs to the greater than signs come from the other branch, and it's just telling you what branch things come from. So let's just say you wanted to keep all the code. Oftentimes, this I would say is the most common thing I do, is I just need all the code. If that's the case, all you have to do is delete the things that got it added in there. You're going to just get rid of the equal signs and the greater thans and the less thans, and voila, presto, you just commit this change and go forward, and there's no problem. But what if you didn't want that? What if you're like, oh, you're totally right, Git, like that's old code, I don't want that. So maybe let's say we were, running our models with the LME4 package, we were doing an MMRM, but now we're using the new MMRM package. So we're going to get rid of everything that came from that LME4 stuff. So in this case, it's only 1 line, but you can imagine a scenario where potentially it's a large chunk of stuff. All you're going to do is you're going to delete everything from the less than sign to the equal sign, and then also just delete that greater than sign at the bottom, and you'll end up with something like this. So basically, you're just going in there and directly editing the code. At the end of that, you're going to commit it, and everything should go through without a problem. It won't let you commit unless you've deleted those greater thans and equal signs. Also, they would just make your code not run, so that's why you need to delete them. But it adds them in so that it helps you know where the conflict is, and it's easier for you to figure out exactly what it's complaining about. So with that, time for another exercise. We did say it was fairly hands-on. So this one is going to be, again, you're working through the app, you're going to work on the merging branches section up here. So work through questions 1 and question 2. Again, do put any questions you have in the question box and do a thumbs up when you're ready to go. And then we will continue. So we have 15 minutes for this exercise, which should mean 4:15, if I'm doing my maths correctly.
That's not what I would like to see, but we'll get there. Cool.
That looks good.
So yeah, that looks good. So the exercise here wants us to pull the updates we have made on the analysis branch into main. And to do this, change the branch. We change the branch to main and then merge. So we check out main, going there. You see that little dot, that outline moved here. We're now back on main, and now we can merge. That worked well. If we undo the change, for example, and say, hey, go back to analysis 2, we check out analysis 2 and would like to merge that, well, that's not meaningful, right? Because we would like for our changes that we did in the analysis 2 branch to be reflected on main. So yeah, just make sure to check out main and then merge from there. That works smoothly. So then we want to pull the updates we have made on the analysis branch into main, but this time there is a commit on main already. Change to the main branch and merge to see what happens. Okay. I wonder what. So we'll try to merge, same as last time. But now, oops, there is a conflict. So remember, the conflict description here basically tells you, okay, you have this highlighted content on head. So everything from the less than signs to the equals is the content of on the head. And then basically everything between the equal signs and the greater signs is on the analysis 2 branch. So we can either keep both of them, or let's say we would like to keep only the changes on analysis 2. We delete all of these confusing less than, equal, and greater than signs, and commit. That's perfect. Now we were successfully able to merge. That's nice, right? So going back to the slides, let's see, where are they? Right here. Yep. What we did in the exercise is we merged a branch into main. And yeah, we checked out different commits and resolved a merge conflict. So that was nice, right? Keep in mind that a merge conflict is nothing to be overly afraid of. We now know how to resolve them. We now know how to merge branches, even though there might be a conflict. And I think this is where you take back control, Christina. Stop sharing.
Oh, you're on mute, Christina. There you go.
I'm so good at technology. Anyway, so now that we've done all of our merging, let's have some quick rules of thumb about kind of branching and merging generally. Branches are cheap, so feel free to make a lot of them. There's no cost having lots of branches around necessarily. The thing you have to be aware of is that the longer a branch grows away from main, whether it's that main grows really far or the branch grows really far, or both, the harder it will be to merge them back in. As we saw, merging in one conflict is not a problem. It's pretty easy. But when you have 30 or 40 conflicts, suddenly it's a lot of work to do. So really the goal is always to minimize the number of conflicts you have. To do that, the best practice is to branch, make an update, commit that update, merge that branch back to main, delete your branch, and then start a new branch. So it's better to just kind of constantly have small little branches. Think of it more like twigs rather than full-on branches. We're going for a very bushy twig type tree rather than an oak or something. I don't know. Now we're really questioning my arboretum knowledge. Anyway, so now we can go back to our case study. So Camille was going to do all of the updates for Journal A. She had everything planned, everything organized, but then she got busy. And so now she actually needs some help in order to do the updates. So to get that help, Sylvie has joined her team. So Sylvie's going to help Camille and to do those updates to Journal A for her, which is great. Now, remember at the beginning of the course where we talked a little bit about Git versus kind of GitHub and GitLab and those sorts of things? That Git is just on your local computer, but not anywhere else. So all of the work that Camille has done up to this point is just on her computer. She doesn't have it online in a place that she could share it easily with Sylvie. Now, a Git project is not really the sort of thing that you tie up and put it into an email, so she's going to need a way to share this with Sylvie. So the best way to do this is these kind of cloud-based services like GitHub, Bitbucket, GitLab, what have you. To do that, what will happen is you will get a cloud-based service and have a repository in that service. Then you're going to be able to mirror what's on your local computer onto the into the cloud. So in Git speak, we talk about things that are happening on your computer as local and things that are happening out in the cloud far away world as remote. So what does that look like in practice? How does that actually happen? So to walk through this with Camille has everything on her computer, right? So she's done her tags, all of that's good. Now she wants to get it to share it with Sylvie. So first thing she's going to do is she's going to go into the cloud and create a repository in the cloud for her to push to. Then she's going to push. So push is just the Git vernacular of saying mirror what's on my local computer onto the internet. So she's mirroring what's locally to her to the remote location of the cloud. Great. Once she does that, Sylvie's able to come down and then she can clone or copy that repository to her local laptop. So now Sylvie has it on her laptop and Camille has it on her laptop, and they have a combined place in the center on the internet where they can share with each other, which is really good. So now Sylvie has the code on her laptop. She's able to make some changes. The first thing Sylvie's going to do is the thing that you guys did, right? Where she makes a branch and then does some commits. Great. So she has something that you guys just had in your exercise. Everything is going well, but she wants to share the code with Camille. So the first thing she's going to do is she is going to push. When she pushes, now that new branch that she created gets pushed into the cloud. And so it is also in the remote. So now she has a local version of that branch and a remote version of that branch. Amazing. Great. The next thing that's going to happen is Camille actually wants to run this code. She wants to be able to not just see it on the internet, but see it on her computer. So in order to be able to run that code, what Camille's going to do is she is going to pull that repository down. Now, the eagle-eyed of you will notice that she did not clone it down and she pulled it down, and those are different words. And that's just because there's a little bit of Git nuance here. But when you clone it, you're copying the whole thing, usually for the first time, whereas pulling it is just going to pull the updates that have happened. So because she already has the main branch and all of the commits with that, she just needs to pull down the updates, not necessarily the whole thing. So that is like the general workflow of working with remotes versus locally. So as with all of the other things we've done so far, another exercise for you. We did tell you it was going to be quite hands-on. So we're going to do another exercise, and maybe Phil will play some more jazzy music. I say 10 minutes, but so far everyone's been super speedy, so maybe closer to 5. But again, ask questions. If you have any questions in the chat box, we'll be around to help. This time we're going to be working through the remote section of this app. So it's the final section. We're almost done with using the app. You will have 2 questions, question 1 and question 2. And then we will come back.
So yeah, showing my new superpower, how to share the screen. Sharing, perfect. So let's see. We're finding branches now. So we have the remote. This is the repository that is located in the cloud. Local is what either we, or in this case, Camille and Sylvie, will see on their local PCs. So yeah, remote's main. We see this network graph here. It has 2 branches. It has the main branch. It has analysis 2. So remotes is definitely the cloud repository, and we're going to main. Should be here. Yay. This feels nice. Then local analysis 2. Local is the version that Camille or Sylvie pulled to their local PC. So it is no longer in the cloud. They cloned it, or they pulled changes from the remotes, and now we're on their local PC. And analysis 2 is the analysis 2 branch. So here we fixed the bug. Correct. So we're now able to distinguish between branches. We know what is meant when people refer to the remote. It is the cloud repository, and your local version is just, well, in this case, a mirror of the cloud repository. Going to question 2. So we're now walking through Sylvie's workflow to make the updates for Camille. First, we're going to clone the repository because so far it's only living in the cloud. So the first thing, in order to get this network graph and all of the changes and code versions to our local drive, we clone this repository. That's what we do. Then we need to check out the tag commit by clicking on it. The tag commit is the bubble in red or pink here. So we're checking this out. Going here, it says code v2. And from this, we create a branch. So we're branching off this tag commit. And we add a commit on this new branch, saying, hey, yeah, now we are in analysis 2. We just have this change and this branch locally. Nothing is visible in the cloud so far. We can also add additional commits. It really doesn't matter. And then once we finish and once we're happy with the state of our code, we can push that to remote. This will make our changes be visible to either Camille or Sylvie, whoever we are not.
Yes, yeah.
Yeah, correct. So now everybody on the project team can see the new branch and the edits that have been made in the analysis 2 branch. Yeah. So going back to the slides here, what we did, sorry, whoo, that is not where I wanted to go. Give me a second. We located different branches. That is what we did in the exercise. We cloned the repo, we created a branch, and pushed changes back to the remote. So no big deal, honestly, right? This was the case study for Camille and Sylvie. Sylvie is part of the project team. Now let's imagine some random stranger, Edward, is now entering the scene. He's some person on the internet who's unrelated to the project, but he wants to contribute. But Camille wants to retain control of her original project, and thus she would like to protect it from outside changes and prohibit Edward from branching off of it. Edward is not able to do that. In order to still be able to use Camille's work as a starting point, Edward might want to fork off of Camille's repo. The fork is basically a direct copy of Camille's repo, where Edward enjoys full ownership. So there he can do whatever he wants. And at a later point in time, Edward can decide to open a so-called pull request, or you will hear people refer to it as a PR, and propose his changes to the original project. Now, again, this project was protected, so there Sylvie or the project team around her have control. They see the changes proposed by Edward and can then decide which parts of the fork to merge into the original project, or rather not. So this is a really cool thing. Let's see how this works. So we see the cloud repository, right? And we see Edward right here at the bottom. Edward would like to clone the repository in order to apply his changes. But he's not able to do that because, again, this repository is protected, so he can't do that. Instead, he creates the fork. So again, we're dealing with the protected repository, but now he creates his fork. This creates an identical copy to that repository, but now he has full ownership, so he can do whatever he wants. And from this new remote repository, he pulls the content to his local computer, and he can now continue working. This is really just a copy of the protected repository, but he is now the owner. So now from this one, he is able to pull and apply his changes as he wishes. So yeah, now Edward is making his changes on his local computer. He's happy with a version of his code, and he would like to push these changes back to his fork. Again, he can push to the fork because there he enjoys full ownership, so no problem. And for these changes in his fork to be reflected in that protected repository, he opens a pull request. So the pull request is simply asking the owner, in this case, Camille or her project team, and it suggests the changes made by Edward. You can see this is kind of grayed out, so Camille can now approve or reject the changes. So yeah, after Camille has reviewed and approved Edward's changes, they are merged into the repo. Cool stuff, right? So as a summary, forks allow for this kind of controlled collaboration outside of a designated project team. And users can create forks, which is just a copy of the remote protected repo where they are the true owners and they can do whatever they want. And hence, yeah, they are able to apply all changes they would like to apply. So to promote their changes back to the original project, they can then open pull requests, the so-called PRs. And the project maintainers can decide whether to approve the PRs or rather not. This is a case you will likely encounter in the development areas of R packages. Write access is granted only to the designated team of the core developers, but not to everybody in the outside world. So if you are a user of that package and you encounter, for example, a bug, and you would like to propose a bug fix, then you would create a fork of the package repository, change the code parts that cause the bug, and then open the pull request to suggest your changes with a bug fix to the core team of developers. They can then go and review your code, see if it makes change, and merge your changes in. Or they can also reject them, like whatever makes sense, right? Here, the owner of the original project is really in full control. And yeah, this basically concludes the theoretical part of this section. We have learned how to read network graphs. We've learned a lot about commits, branches, pull, push, how to clone a repository, how to differentiate between our local repo and the remote. And finally, we learned about forks. Cool stuff, right? And now we'll have a 20 minutes break. This part is going to be a hands-on session where you can follow what Irene is doing. Irene, do you want to?
Now let's see if I manage the screen to share.
I know, it's super hard, right?
Okay, so this session has, Alex said, is going to be very practical. So the idea is that you follow along if you can. So we will go as low as possible as needed. And I've seen that there were a lot of questions that we said we would answer here. If I forget something, just again, rewrite it or just let us know and we will try to cover everything. So managed to share but not to move the slide. No, so what we will cover. The idea is that we will, for this course, we chose GitHub. As was said at the beginning, other platform works exactly the same. It's just this one that is the most used. So we decided to go for this. And we'll show you how to fork a project and why we will have to fork the project and not clone it. And then we will have to do a little bit of setup because we will have to set the Git identity in a way that you can actually commit and the system will be able to know who has commit. And then we will have to link your environment that you're using, so the POSIX Cloud, to your GitHub. And then we will try to follow along and make commit, push, create branches, merges, and at the end to do a pull request. This is actually kind of what happens usually when you work on an open source project. You will kind of follow along those kind of procedure. So the prerequisites are that you have access to Posit Cloud, but as this has been solved at the beginning with the app, I think it should be good. And then that you have a GitHub account. If you do not have one, you can just follow along. I will share my screen and basically it will be the same that you would be doing. But this is the prerequisite.
You can
This
also
course,
make a GitHub account. It's free and it should be very quick. But if you don't if you don't want one, you don't have to have one. You can follow along, but you can get one. They're free and easy to get. Like Posit Cloud, takes about the same amount of time.
yeah, good point. And this course is really based on Git integration with RStudio. So we will show you mainly how to work with the GUI, with a little bit of exception for the terminal. We'll show you along. But so if you have a question, just ask. Doesn't matter which system you want to see. So we will start with the project that actually we have kind of used more or less through all of the examples. So the link has been shared, I think, right now even. Alex has shared it. So you should click on it and we will just look how GitHub looks like, where you can find information, and then we will get the code and fork it. Like this, we will be able to start working. Okay. So you should be able to see the Git that was shared. Let us know if you have any issue. And as you can see, this is a project that is located on KGaA Ames, so you can see where it sits in the remote, in the cloud. It is a public project, so meaning you can see the code. This also means you cannot, unless you're part of the project, you cannot just get it and make changes. So just 1 second, I'm going to try to keep the app going. Actually, can you hear me?
Yeah, we
Yes.
can hear you.
Ah, I actually could. Okay, it went blank. I have no idea why. And now I can actually even see the chat. Cool. So what I was saying is that this is a public project. So as you're not part of it, you will not be able to just get a code and make changes. That's why you need to fork instead of clone it. And there was a question before, you could see if someone had forked the project, and actually, yes, you can. You can always know how many forks have been made. And a very nice tools that is in GitHub, you can go in Incyte, and if you look at the network, you basically will see what has happened until now. So here, for instance, it's a very simple project. You have a main branch, you have a second branch that hasn't been merged back, and you know that there is only this location. Every fork that you will be able to see it here. So you have a good track of whatever has taken your code. Now, if you go back to code, as we said before, so if you would be part of the project, you just copy the URL and you would be able to bring it down to your location by cloning it. Here, we don't have the right, so if you would try to do that, it wouldn't work. So you would have to perform a fork, and you will have to do it here. It's good if you're already log in into your GitHub, because when you click create a new fork, you will see that here it already appears my GitHub because I'm linked, and maybe you will see the same. Otherwise, you might have to log in. The default is to only copy the main, because usually when you want to propose a change, you want to change the main. So we will leave it. So like this, we'll only copy the main branch and it will just be easier. So just need to create a fork. Might take you a little bit, and then it should bring you into your own GitHub. Now, as you see here, I still know that I've been forked from a place, but now it's located in my own remote. It's my own place, so I own this code. I can do anything I want. So, and this is when you fork, you're now the owner, you can do everything. And this means that at this point, you have it on the remote. So when you do a fork, it goes from the cloud in a position. Yes. And the network graph, you need to go inside here. And then it's network. Actually, this is nice because we know we took it from here, but now the main branch is in mine. So we can see that we have it. What we will have to do now is to take this code and bring it into Posit Cloud because we want to start working on it. This means we will have to clone it down to your workspace. This means you will have to copy here the URL, the HTTPS, and go back to your Posit Cloud. We start a brand new project, so you will have to go on your workspace and you will have to click on new project from Git repository. And you tell me if I need to stop because I don't manage to read the comment, okay? So this should clone your project from your own GitHub directly in here. And it will take a little bit, but you should see the same code that was in GitHub directly here. I see that there are a few questions about that. To create the fork, it's in the original Git. It's up here. And I see that 29 have been created. It's a good sign. And back in Posit Cloud. So now we have our classical RStudio and everything has been brought down. As I was saying before, we will do a lot of the action using the Git GUI. That's here, just on connection and tutorial, and all of the main action are down here. Again, this is to perform simple action. You can more or less do everything. Complex things, unfortunately, they're not covered here, so they have to be done on the terminal. But in general, for your normal workflow, you should be able to just use that and perform everything. So here you see that everything is white because nothing has changed. Now we are up to main, and if you want to explore and if you want to go to see what has happened to this project, you can go in history. And this is very similar, with less fancy than what you see in GitHub. So you have the chronological information of all of the commit that happened with the code. So you can actually see what has changed and what has not changed. You can, by looking at the color code, so Git tracks by line. So anything that has changed, it will know if this line has been modified or not. And it will be red if it's been deleted, and it will be green if it's been added. Like this, you can see all of the changes, and it's pretty nice because you can compare code. Here we only have main. We only have one branch because we only cloned that. So right now is a very simple structure. As you see here.
Can you go back and just show the forking one more time for people? I think there's some people who are a little lost. I think that happened quite quick.
Okay. So you need to go to the PSI AIMS Git training. That is the first link that was shared. And it's here. So you will have to click on the fork. On here. Sorry. And then create a new one. Well, I already created one, so it doesn't work. Sorry, but that's the process. And when you go through it, it will and you click on fork, it should bring you to your own GitHub, and you should be able to see the same in your own GitHub.
And then just
In
make sure
POSIX,
that when you're going to make your new project in the POSIX cloud, that you're copying the URL from the forked version, not from the PSI Ames version. Because if you go from Ames, it will say you do not have access to do so. And that's because you're trying to clone something you don't have access to. So remember how we were talking about the difference between forking and cloning? That's when you're going to need to clone your forked version.
and to the question, if you create a new project, you just go to your workspace, create a new project, and then is new project from the Git repository. And in there you place your GitHub. Let's just see if there is any more question about it before we start with the next setup.
Yeah, I think it's getting your head around forking the repository and that being your duplicate, if you like, of the repository. But then in RStudio, you don't have that project visible. So you have to go do new project and link through to that fork that you've done to tell R what project you want to be working on. And I think that might be where people got a little lost.
Yeah, just remember that the fork is always in the cloud. So you're right to think of forking and cloning as very similar, except for cloning takes it from the cloud to your computer, and forking takes it from one place in the cloud to a different place in the cloud. So we need to go from one place in the cloud to a place that you own in the cloud, and then from the place you own in the cloud to your computer. So you're going to fork it, and then you're going to clone it. Okay. Think it looks like people have caught up. It looks like we don't have questions. Irene, you can go back, go forth.
So right now, what I was showing you before in the history is like, you can see that basically the only person that I've worked is actually Christina in this, and you have her name everywhere. And Git needs to know who has made a change to be able to say who has committed a change. So this is going to be a little bit painful because we will have to set up your Git ID, and then we will have to set up a secure connection between this, that is, you kind of can consider this as your local machine. It's just your environment that you're using now, just your local place. And you will have to be able to link this with your GitHub account. Because right now you just clone it down. This is it's a public project still, but you won't be able to push back changes unless you have securely linked the two. There are several ways to do so, and we have picked one that in theory is the easiest. So when you have this project open here, you should see the file system on the bottom right, and you should click on gitcred.r. In here, you will find the code that is actually needed to help you set this stuff up. This is a new instance, so you will have to install a few packages. So you can run line 9, and it will instead two packages that will just basically help to set up your credential. Take a little bit of time. Let's see if everybody has found this file. Done. And at this point, you will have to tell Git who you are. So in here, you will have to write your username. That's what then will happen. It will appear as your name, the person that has done the commit, and your email that is used for your GitHub account. And these are the two main things that will be needed to do this part. So. You will run it and you should not see anything. So you should just, you will not get a message that this has been set up, not just by doing this. But now Git knows who you are and what's your email. And the next step is to create what's called a personal access token. It's basically a long string of letter and number that will link. Yes, what Alex is saying is that if you have everything set up local on your machine via SSH, via anything that you have, you can, of course, skip this. You will then have to use your local machine. You won't be able to use the POSIT Cloud, but it's totally fine. For everybody else, just run the create GitHub token. This will open again your GitHub page, and it will open it to a page that I'm going to show you on the slide, because I will have to set up that as well. And the token is something you don't share. It will bring you to a page in which you basically need to, it's already pre-filled. All of the setup are done. You will just have to write what is the token about, just for you to know where are you using this one. And at the end of the page, you need to click on generate token. Now, what's in, again, you need to run the use this create GitHub token to open the web page pre-filled. Describe what your token will be about. It can just be R for Pharma course or whatever, and then generate it. Now, what is important is that you will see a long string of letters that start with GHP. You will see it only once, so you need to copy it, because you won't be able to retrieve it after you have clicked that you're okay with it. You really need to copy it somewhere safe, and then we will move back onto the you will have to move back onto the POSIT Cloud. I will leave you a few minutes to do that. What about now?
There you go. It's done.
Oh,
It.
good.
Third time's the charm.
Yeah, it didn't like that I share my desktop. I wanted to share only this. So it means I will not be able to go back and forth. So if you run line 22 in the same file of the Git credentials set GitHub path, if you just run that empty, it should open here a pop-up where you enter the password. So you just copy it. Okay. And don't get freaked out if you see that there is a cache timeout. It's fine. It should anyway work. Can you increase the size? Yes. Better? Okay. At this point, you can also just to make sure that everything has been set up correctly, you can run line 33. And this it basically gives you an overview of more or less what you have. At the beginning, you will see that personal token has been discovered. So I'm set up, it's fine. Hope you all are. So to check a bit more.
No, you're fine, Christina. Irene, I think it's fine.
You think it's fine?
Yeah, I think you increased it after that message.
Okay, sorry. It's slow. And I guess you, yeah, well, now I can only share one screen, so I cannot share anymore the PowerPoint. But yes, when you open the token page, just write a name, go at the very bottom and do generate and copy that string. And we swear this is the last setup we do today. Then it's fine. Okay. I guess we can go ahead. So what we're going to try to do now is we're going to do all of, I mean, it's going to be a little bit artificial because we want to try to show you several of if you're using your local RStudio and it's set up to Git, there is absolutely no difference. You are in your own GitHub, you can clone your project, so you can use your local. It's just that sometimes there are a lot of restrictions if you're using your work computer, but if you have complete admin and you're using Git, you really don't have to use Posit Cloud.
The only other thing is you need to make sure you have Git installed. So Git is actually a software that so if you're on a work computer, you probably have a software center or something of a various name that you probably maybe can install Git from, depending on what your work computer's rules are. Otherwise, can't remember where you I can't remember where you download it from the internet.
Yes.
Yeah,
I'll put some instructions in the chat box.
Perfect, Phil. Thanks.
Yep.
Otherwise, it's on the internet, and you can get it there. But if you're on your personal computer, but yeah, you need to have Git in order to have. So part of the biggest reason we're using Posit Cloud right now is because Posit Cloud already has Git installed, so you don't have to install any software.
And we are sure we can make the
Installation,
connection.
I think we have the link to the installation page in the appendix.
Maybe.
Yes.
Yes, I think that is the first link we are providing in the appendix.
So what I was saying is like now it's going to seem a little bit artificial. We're going to try to do commit and we're going to do branch and we're going to try to create a conflict. Like this, we can go through how to solve it. So it might seem a little stupid, but just consider that the changes we're making is just an example of how you would be able to work. So what we're going to ask you is to actually, first of all, I forgot to say, an important part of this Git GUI is that you know where you are when you look at here. So right now you see we are in main. We actually, if you check, there is only one, there are no additional branch. There is only main. And you can see that locally we have main. And well, in the remote, there is only main because this is by remote. So we only forked main branch. So this makes sense. And what we will do after is to create a branch and we will switch from one to another. To avoid too many conflict, because we're going to do a pull request at the end, what we're going to ask is to just copy this file, the readme if I can speak, just copy it and just add your name at the beginning or something like this. At least we will just create a new file. You will have conflict with yourself because we will make it happen, but it will just simplify the work after. Now, let's just make some changes. This is a Git training. In a README, we can say, and I excuse myself because I make a lot of typos. We just say that we describe the training. And that's it. Now, here I made a change. I save. And you can see that this has popped up here. I made a change before on the Git cred when I added my name, but we will look at this after. So now we have this file that I actually want to commit because I'm happy with the change we have done. And to do so, you need to stage it. So stage it is a concept that basically, so Git will track when you decide that you want to track a set of changes. If now I unstage this and I make new changes without committing it, from this version that you have here and what I change after, Git will not be able to tell. So you will, when you're happy with your changes that you have, you need to stage it, meaning at this point, if I do a commit, I'm happy with this version of the file, I want to take a snapshot of this. But by not staging this file, I'm not going to commit this file yet. So I'm just happy with this. So you click on commit here, and it will open actually the same page that we looked before for the changes. But now we're just looking at this file. here is nice because as usual, it makes you see what has changed.
Irina,
Here
because you shared only that screen, we can't see the
oh
pop
no.
screen.
Okay, I need to try to share my desktop. Let's hope that this time it works. Let me know.
Yay, it's worked.
Worked.
Okay, so now we see the pop-up that after you click on making a commit, it will come up. What is nice here is that, I mean, everything is in one place, so you just write your commit. And for a question before, because I've seen in the chat that there was a question about if I can change the message of a commit. Just if you click that, it will actually change the latest one. You can change any commit, it's not great, but just by doing amend, it will join the last two. Here we are happy. We do a commit, and we can close this, and you will see that now we are back to only have the Git cred because it's the only thing that has changed. So basically this file that we have modified and commit, now we don't see it anymore. But it's still only local. We haven't pushed it back. So my remote hasn't seen that I've added this file. To push it, you can just put on the push arrow. And as we have set up the pub token, it's saying that it's pushing back the change into main. Now, is everybody okay?
Yeah, we're all good. I'm just,
Okay.
don't worry. Keep going.
Yeah.
You're good. You're doing great.
Because I see you big in the screen and I see you with a face like, ah!
No, we're all good.
Okay.
I will try to have a more joyous disposition.
So now we have, if you go back here, we see that we have the Git cred that has been modified. So now, for instance, you want to see what has been modified because maybe you've done something by mistake. You can click on the diff, not on the commit, well, also on the commit. And you see that here I've actually added my name. Maybe you don't want to do that. Maybe you want to keep this file just as it was to be the template. You can just do more and revert. If you do that, it will tell you that you're going to lose changes. You say yes. And actually what we have done is that the Git cred has gone back to the original form. And yes, and we're good. Now, let's look in the history, in the Git history. And now you see that we have a new commit, and there is my name. Now, let's say that you also want to work on something else. You want to start to create a part of the Shiny app. So you don't want to mess up with this. So you're going to create a new branch. Like this, anything that you change on this branch will just stay there. And until when you don't decide to merge, it will not influence main. To create a new branch, you can use the GUI. You need to click on new branch, put a name. Cannot spell right. And as you see here, there are already some default that are clicked. So sync branch with the remote, it means that you are creating your branch, but you're also mirroring back to your own remote. So after doing that, if you go back on GitHub, you will see that there is a second branch. It's not only local, it's also on the remote. Basically, you will be able to store what you change in this branch back. If you click create, here you see quite a lot of code. Just for you to know, very often what you have here, it's code that it's the Git command to do what the GUI is doing. So when you create a new branch, through the GUI, you are automatically in there. So as you see here, Irene branch, I've been moved there. So it means anything that I change here, I'm actually only change it in the branch and not in main. Now to continue our example, we can keep changing this file because then we will create a conflict. And you can say that in line 3, we are developing a Shiny app. Now, same as before, you need to save, commit, and commit needs to be a lot more precise than what I'm doing here. I mean, they need to talk to you. You commit, and we're going to push back. Now, here you can see that as we were working in the branch, here is push back to the branch, not in main. So you're not affecting anything that is in main. Right now, so we were in main, and a branch has been created, and there have been an additional change. This is, branches. This is still linear just because main hasn't changed. So now we're going to try to create a conflict. And to do that, we're going to go back on main from the top right. And here you were saying that you switch back to main. So in Git term, that's what the term that was used during the course, you check out to main. And as you see, our code has disappeared. So what we have changed on the branch, it's not here. So if you switch back, it's back. Same file, same everything, but you're just into parallel branch that for now they're not talking. No. So let's go
Irene,
back
we
to
have
main.
a question in the chat about the history. Could you briefly show this again, please?
The other thing, Irene, can you make it less wide, your Git tab bar, because it does collapse a little bit. So you lose the word history when it's skinny. So you can see when you,
yes, it's here.
You've made it skinny. So you click the clock.
Yeah.
But you want to make sure it says, the tab at the top says Git, as opposed to saying there's a tab that says history.
Here.
It's not that tab.
I did it 3 times though, so.
Yeah, that's the history of the code that has been run. This is the history that is the history of the Git commit to look at the network graph.
And for now, the network graph doesn't really look what you might have expected, because maybe you were expecting the branch to be off just because it's a branch, but for now, main hasn't changed. So it does seem linear. Well, we're going to change main, saying that we are adding picture. Save, usual, commit. Now we're going to commit and push directly. And we were in main, huh? So we push back in main. Now, if we look at the history, and you will have to click on all branches, otherwise you will not see, because the default, it always go back to either one or the other. You see that now we have actually my branch where we have started to develop the app that now is back. So right now, those two have diverged. And as we have changed the same file on purpose, they will conflict. Okay. So right now, there are several ways to perform merge, and there were questions before about the different type of merge. As I said before, we are using the GUI and the GitHub as much as possible. And so the first time we will show you a merge is going to be through GitHub by actually performing a pull request to yourself. It seems very strange. The other option that we show you after is in the terminal. That I actually realized I haven't showed you that there is a terminal. So in RStudio, if you go next to the console, there's a terminal. And this is a full terminal. And if you need to write any Git command, it needs to go here. So just the most classical one, it's Git status to see what it is. And for instance, it tells you that you are on main, you're happy, there is nothing different. This is a lot of things. So all of the things that you perform through the GUI, they translate into Git command. You just don't see it. But so what I was saying is, like, for now, we're going to go through the method through the GUI, and then we will do the terminal way. Local merges are a bit of a special case, because actually doing to the GitHub, it's a little bit convoluted, but we stick to the logical discourse. And the question about the different merge, so maybe you can write a little bit more. I guess you were asking between a merge and a rebase. I'm not sure what you were asking about, the person that asked about the different type of merge. So maybe if you can write in the chat, we can go quickly through. Okay. Before going there, I'm just gonna super quickly go again over the branching, as that is the question. So the branches are handled through the GUI and this part. So if you click on the arrow next to main, so what is written here, it's where you are. So which branch you have checked out, meaning where if you make a change, it will stay in there. Now here you can see that two branches exist. One is the one that we have created, in which we have developed the app, and the other one is the main. And we have both branch available in GitHub. You see they are in the remote. To create a new branch, and again, you can create as many as you want. That was Christina was saying, they're cheap. We'll show you how to delete them if you don't want them, but you can create as many as you want. And to create, it's the purple box, and you need to write a name, and again, leave the default as they are, because it's nice. It's already pushing back to the remote. This branch is gonna be mirrored. Otherwise, it's just local. It's not very useful. And
the other thing to think about as you're going between the branches, it's just like what we did on the app with question 2. Yeah, so that is Sinead that is exactly what I was saying, is that so head is where you are. So what it said in the kind of, because it says main over on the top corner, I'm pointing at my screen, which no one can see. Because it says main, it means that that is where you're located. So you'll see here when she's looking at the history, that the origin/head, so where you are, the head is where you're located. So in the app, had the thing that told us where we were was that little black circle around whatever commit dot. In this view, it's going to have the wording origin/head. So, but that is the head that I was talking about when we talked about it within the app. And origin/main just tells you, so the origin is another name for the remote. By nomenclature, it's referred to, the remote could be anywhere, but the specific location for us is the origin. So the origin/main means that is what is online. Like that is the thing that is on the remote is there. I mean, you're probably going to go through all of this and it will make more sense.
No, I think it's great.
Because if you do a commit here, but you don't push that commit, you'll see that the origin main and your main end up in different spots. until you push it.
Yes, and those are both pushed, so that's why you see it like that.
Yeah.
And for the question about, so when you merge, there are different strategies that Git allows you to merge, and that's going to be theoretical because we're not going to do it. So you can merge because the Git command is actually merge. And what you do is that you create a new commit that is a merge of these two. And I'm sorry if I'm doing this Windows here to answer the question. The rebase is slightly different. You will bring this branch that you want to merge and bring it in front. So it actually changed the history. It's not gonna add a new merge commit. You're just gonna move the one on top of here, and it actually kind of you lose the history of the commit, but there are cases in which one is better than the other, and I guess also personal preference.
Generally,
I am for merge.
yeah, I was gonna say, generally for the case of pharma, because we do like auditing things and we do like histories, we don't generally recommend rebasing because you lose that history. So that's like a very broad, you might do something differently, but for the most part, we're gonna say merge, or go through a pull request. When you're doing pull requests, it can be important to do them, which we're going to cover in a second, particularly if you're doing like package development, you're helping with an open source package, you want things to go through pull requests if they have something called GitHub Actions associated with it, which is basically just a way to run a bunch of automated checks and things like that. If you have automation involved, you can't do things locally. If there's automation, you need to do things in the remote.
And that's what we're going to do now.
Yeah.
Just to show you how you can merge your branch into main through GitHub. So if you go back to your GitHub, meaning your, so mine is my own name, not the PSI one. You will see that now you have this yellow box that is basically telling you that there is a new branch that has new pushes. So what do you want to do? Through the system, you can merge it by going through it's basically an assisted merge. You will have to click compare and pull request. I know it's a little bit weird because a pull request you usually associate with, I send it out my code and decide yes or no to bring it in. Here, you're basically asking a pull request to yourself, but it still makes sense in terms of how you merge things. So you're gonna click on compare and pull request. And I'm gonna ask you to just be careful because the default is PSI. Because usually when you do a pull request, again, it's to go back to the original project. So you will have to select here what you want. Now there are all of the different forks, but I'll choose mine.
Irene, can you stop sharing and reshare one more time? Because it seems like there are a couple of people with problems with your screen.
I think that must be their end because if we can see it, then it's obviously showing okay from Irene. So I wouldn't, Irene, in case it stops.
Fair enough. Good point.
I'm sorry.
I think if some of us can see it, then it's obviously not Irene's end.
This is just maybe just a little bit slow. Here, my connection should be fine, but
you're good. You're good. I'm sorry.
I'm gonna get no worries. So as you said, you need to select your own version, not the one on PSI. Otherwise, you're just gonna do a pull request to Christina. And then you basically here you see the error. It's basically saying you're gonna get the branch into main. It's already telling me that I cannot do automatically because we changed the same line again. Git tracks line. So if we would have changed different places in the file, we might have been able to do it automatically. Not in this case. So yeah, here it reports what's your last commit. What's nice is like here you can write, of course, not to yourself, but when you do a real pull request. And you do create a pull request. So it's gonna tell me that I cannot automatically merge, as you can see here, and the conflict needs to be resolved. So you need to click on resolve conflict. It will open a text file that is basically the same that you saw in the exercise before. It's the same concept. You have the symbol that describes what it comes from the branch and what comes from main. Let's just say that here we want to keep both because we're happy with the development of the app and with adding the picture. So you will have to take off, as we saw before, all of the weird symbols. And once you're done, you just say that you have resolved the conflict. So you're going to mark as resolved and you're going to commit. So this to go back is a merge. So you're creating a commit specific for the merge. It's not a rebase. You're going to commit the change, but you're not done yet until when you don't do merge pull request, it actually nothing has been properly merged. So we're going to do merge pull request. You really want to make sure that you are sure. Confirm merge. And you're good to go. Now, here is even proposing you to delete a branch. From GitHub, you can only delete remote branch, not the local one, and we will see that after. I will leave it, but you know that you can do it from here. Because very often the process is, as Christina said, you make a change, commit, go back into main, you're done. You can delete that branch. Now we're going to go back on the POSIX Cloud. And what we're going to do at this point, back in main, and we're going to pull. So we're going to get the changes that we have made in GitHub with the Git merge, basically. And it's going to tell me that it's bringing down stuff. And indeed, we have the version that we have merged on the system. Okay. Why did I take offline without even realizing? It's a bad sign. So this is the merge through the GUI. Now, what we can do is to actually say, we're happy with the changes we've done, and we're going to try to do a proper pull request, but this time to the original project. And yes, so I will go up to the pull request again. I cannot do the same anymore just because the branch doesn't exist anymore, but we're going to do a pull request to Christina original project, and you will see that it's basically the same. So all the pull requests need to be started from GitHub. You cannot do anything from here. So if we go back to the GitHub code, now you see that at this point, I don't have the yellow box anymore that he was saying, I have a branch that is ahead of main. Do you want to merge it back? That would have been what we did before. But at the same time, there is something here that is relating to the original project. So you can see that there is a contribute and there is a sync fork. So this will go over after if we have time. Sync fork will be, you've made your fork, you took time to make your changes. Now you want to go back to the original project, but maybe the original project has changed. So you can actually not do it directly. First, you need to integrate the change, make sure that everything is fine, make sure that the change have not broken your code. And when you're really happy with it, perform a pull request. Right now is the simple case. The project hasn't changed. So we can go directly and do a pull request. And the pull request can be started from contribute here. And open pull request. And he's telling me that I'm 5 commit ahead than the original one. To go back to
Irene, can you make a version? Can you just finish creating that and then show people how to change their location once they've made one? So like once you've made a pull request, you can go back if you've sent it to the wrong location, which some of you have. I've messaged everybody who has sent it to the wrong location.
Ah,
You need to go back and change your destination, which should be super easy to do.
here,
But
right?
yeah, but you need to, if you finish making it, so if you make this,
Yeah, you need to delete it actually.
do you need to fully delete it? Okay,
Yeah, you can change. No.
fair enough.
It's what I did my mistake yesterday to you. So.
There we go. It's easy to do, but it's not hard to make a new one. It's just a click of a button.
I think you cannot, but we can check. Merge with original project. Okay, the idea is here, if you're actually working on an open source project, you will want to be very exhaustive in the change you made. You can write the changes you made and etc. So this need to consider that as a conversation with the developer, because it's going to help to know exactly what you've changed and what are the news. It's actually it's my markdown type of writing in here. Now I'm not going to do it, but just, and I'm going to create a pull request. In this case, it should be able to merge automatically, but it shouldn't allow me because I'm not part of this. So right now I cannot do anything anymore unless you close the pull request. And that's also a way how you can, yeah, what you said. If it's on the wrong location and you do close pull request, you will
I
not
think you can go all the way up to the top and hit the edit button and change it. Edit to the right-hand side.
Oh,
And then your base, you can change it to a different place.
I'm blind. Where?
Yeah, no, where
In
you
here?
clicked, I think you would just have to put it in. I think it would, you can choose a branch that is.
To go to though. Here's between main and analysis.
Yeah,
I'm merging
enough.
into.
Fair enough.
Don't think
Never
you
mind.
can.
Take back what I said.
But you can
Time to
close
change
it.
but
And
not that much.
side note, if you close the pull request super quickly, you're gonna get a badge on GitHub saying that you've been really quick. No joke. So right now, actually, I think, Christina, you need to share your screen because I cannot do anything anymore. I need to wait that she approves what I've done.
Yes. Okay. So now if I'm here, I see people have been doing merging pull requests, which is great. I'm going to go to Irene's one. And then I can merge this pull request and approve it. So confirm merge. And now, actually, yeah, you're not going to see it, but everyone else will see that they can sync the new stuff. So if we tried, I'm going to pull in somebody else's at random. They've now added a new file that says Amtha's copy. Just double check it. Okay. I merge this pull request, confirm merge. Great. I'm going to stop sharing. And Irene, do you want to go and see about updating your fork? Because that was a question.
Hopefully you can see my screen. Let me know when, since we had an issue. Okay, so right now, Christina's changed her version. So this means that I cannot directly bring down from here what we were working because this environment is linked to my own version of the project. So this means that you need to go on. Okay.
Code is
In
the
your
thing.
version. And what you will have to do is to sync. So I actually accidentally went to my work Git. That's why there was only one thing. So you will have to sync, and it's telling me that the branch is out of date. It's telling me how many commit I'm behind. So we're going to update the branch. Again, as we have different files with different names, here was not a conflict. I could directly get it. All was good. Otherwise, it will again open the GUI to merge conflict.
Someone's asking a little bit about the merge, about me pulling things in. Let me run through that a little bit slower. I went super fast, so I'm going to steal back the screen for 1 second here. Okay. So just to explain a little bit more about what's happening from my side. So I am the lead developer, what have you. So I have the authority to merge things in, but Irene doesn't, because remember, the whole reason she needed to fork this is because she is not part of the team. So because she's not part of the team, she had to do things in the clone or in the forked version. So because she's in the forked version, here I'm going to pull through and do someone else's. I'll do docs. So I'm going to have a view that looks something like this. One of the things that I'm going to do, because this is the kind of thing you should do when looking at pull requests, is before just merging this in, I'm going to look at the files. So I went to files changed, and I saw what Vikrat did. Honestly, I was just checking to make sure no one accidentally put their password in, but fundamentally, that was all I was doing. I was just checking what the files had. So now that I've seen what those files are, and I'm happy with them, I can merge this pull request. I'm the only one with the authority and the decision-making power to do this pull request, to do this merge. And so basically, now I'm going to merge it. I've checked the code, merging it in. When I confirm the merge, now if you all sync that, you'll also be able to see Vikrat's version of the code. So now if I look at my code has 3 files. Irene's file, because that's the one I did first, and then 2 other people's files, because I did 2 more pull requests. So the reason I did 2 pull requests is mostly so that Irene could see. One, if Irene tried to sync, it would say there's nothing to sync because her version was the last version I pulled in. So it was really just to allow you to see the syncing. So I pulled something else in, but now we have 3 things. So we now have 3 files. Fundamentally, that's that is how pull requests work when you're working on in the open source. Is you typically have to ask the main developer, hey, can you accept my changes? And they will look at your code, and then they will probably accept your changes, or maybe ask you to do some modifications.
So in the setting of the case study that we had back, I think 3 hours ago almost, Christina, you are Camille. You are the project owner. You have all the authority on your repo, and all of the other people who want to merge their pull requests be merged in are the Edwards. Like Christina has authority. She reviews all of the changes. She approves them or comes back with wishes for change.
Okay, so for the protection question, I'm gonna go back to sharing, and then Irene, it's all you. So the only thing about protection is protecting branches is generally a good idea if you're working with a lot of people, but as we've seen, you guys can't push anything into mine unless I've approved it, because you guys are working on a fork. So when you protect a branch, you're protecting it from your team that is has access to read and write. What you're going to do is you're going to go into settings, and then you're going to go to branches and then add a protection. for the most part, you're not really going to need it, but there's a lot like of guidance about it. I don't want to spend too much time on it because it's a little bit of a side thing, but yes, you do want to add protections, and the branch name pattern is probably the hardest bit, which is not that hard, but basically sometimes you will have a lot of different versions of a branch of like so maybe you'll have multiple versions of dev or something like that. So you might say dev star, which would say apply this branch to all things that are called dev. We're going to just apply it to main like that. But I'm not going to apply it because I'm the only one who's on this team, so I don't need to protect it for myself. But anyway, Irene, back to you.
Okay, so let's see if I get granted. Should be work. Yeah. Well, waiting for your confirmation, but it should be working. So at this point, as well, actually now Christina has merged other stuff. I have done the sync. This is going to be actually a good opportunity to show you how to perform a local merge from main to your branch. So from main, I pull and I get the extra file that from the latest pool thing that Christina has accepted. Now, if we go back in you see I also do that history all the time, in history, and you select to look at all branches, you can see that right now the head is here, and there are the results of the pull requests that I brought in. However, I had my old branch here that actually doesn't have all of this. What does it happen if I
Sorry, we had a question about the head. So whilst you're on this tab, do you just want to explain the difference between the origin main and the origin head again, just briefly?
I actually found it extremely complicated myself. It's just that the head is where you are.
Well, so technically the origin head is where it is in the origin. So you remember, anything that starts with origin / is what's going on in remote versus locally. So functionally, it doesn't really matter too much where the origin head is. You can kind of ignore that. The thing that matters to you is where your head is, and that's where you are. So because Irene is on main, her head will be on main. You can do some fancy things and have what's called a detached head, which means that you're not at the end of the branch, which is what we were kind of playing around with in the app, where you would check out previous commits and then go there. You can do all of that. We're not. Mostly just for simplicity, but it's definitely possible. But yeah, for the most part, the only thing you really care about is where the little green thing is.
Yeah, now before the head was in main, because if we would have changed anything, it would have been there. Right now, I switch back to my old branch, and you see that the reference to get it here. So it's telling you where you are.
I think that makes sense.
Yeah.
To me.
Now we're going to try to do this local merge, and we're going to do it through the terminal, just because it's something that might happen. If you want to do something only local, you just want to, in this case, you want to bring whatever is in main into your branch. As you saw in the exercise, to be able to merge into something, and this can be a bit convoluted, you need to be in where you want to merge into. In this case means we need to go to the branch, and then we are going to merge. So we're going to do git merge, and we're going to rate main, because that's what we want to merge. We are in this branch, and we want to merge into main. And Just by doing that, we have brought back all of the files that were into main into my branch. In this case, there were no conflict. If there would have been a conflict, PosiCloud is set up that it would open a file here, a new file, that is the commit file, where you will have to select, as you did before, exactly the same, taking off the weird sign, the weird symbol, and it's going to be exactly the same as what we've seen in GitHub. It's just a little simpler for certain things because you stay local, you just want to do local. Now, we wanted to cover another thing that you actually cannot do from GitHub, that is actually to delete branch. So right now we have, for instance, a new branch that I've done my mistake. And you want to delete it locally, because again, on the remote, you can do it through GitHub. So we're going to move to main. And to delete a branch, you just need to write git branch, because all of the comments related to branch are branch, -d, because you want to delete it, and then the name of the branch. Of course, I don't remember right now. New branch, that was it. And you have deleted. So you will not see it anymore local. Again, it's sometimes good practice to take off if you have many local branch. No, unfortunately, not everything can be done without using the terminal. I don't think you can delete local. Maybe I'm wrong. I'm not a very strong user of the GUI. I don't think you can delete.
You have to do this on terminal. You can't do it any other way. So if you've made a bunch of branches, and even if you've deleted them through pull requests and things like that, they'll still be local, even if there won't be a remote version. And like here, it's the opposite. Irene hasn't deleted the new branch in the remote. She's only deleted it locally. So you can see it's under the remote origin tab, but not under the local section. But I think the opposite is way more common, that you end up with the thing not being in it's not in remotes anymore, but you still have a bunch of local branches hanging around, kicking around. That's how you're going to delete them, that -d.
Yes, and I would say another thing that it's actually easier to do through the terminal, unless you do it through the release on GitHub, is actually tags. Those are probably the two things that you might have to use the terminal. And in the slides, you will find that there are a lot of reference at the end, and there is like all of the main comment on terminal that you might end up using. Usually, if you do all of your merges through pull requests, because you're working on open source and you have everything set up through some jobs, so you have all of the check done, besides deleting branch, you probably don't have to use the terminal. I see that there is a new question, and then Alex, I might leave you the floor because.
So we have a couple of questions we could go back over.
I guess you can delete it by just doing kind of a grep on the name. If you have like all of the, potentially you can delete all of the branch together. We'll have to check in -d.
You definitely can, option. And I just don't remember the code to do so. I look it up every time. Very possible. I always look it up.
That is something where ChatGPT is absolutely, yeah, reprex, just stuff like that, highly recommendable.
This usually works with reprex, let's say. So if you want to add stuff that you want to add there, you can do by asterisk and point. I guess it would work also there, but I would be surprised that there is not an option somewhere that says, oh, it's like, yeah.
So one question we had a little while ago was, can we copy files from one branch to another or into main without necessarily doing something like merging? And I think that's probably a good thing to address.
So kind of no, but also kind of yes. So you're completely allowed to use copy and paste. Copy and paste still exists. But also what's more likely to happen is like what we've seen here, Irene's copy of the README and the Amtha's copy of the README both ended up in this branch, or in her other branch. Wait, even if you go to your other branch, it will be there.
But no,
so
yes.
Originally, they started in other people's branches, and then it ended up in the kind of origin one, right? The original Camus one, through that sync function to sync her fork with the original. She got the files onto her main. And then once she got the files onto her main, she used the merge functionality to do that. If you have, say, a big project with like hundreds of files and you're on a branch with, and you only want one of those files and you don't have 50 of the files or something like that, first of all, just be careful what you're doing. But let's just say you only need one file, you want a specific file, and you specifically don't want any of the other files, then there are times I just use copy and paste. Like it's just not worth trying to be fancy yet.
Potentially, and I don't think it's a good practice, let's put that out, but you can also do it from here, because here you can add a file. So you can be in main on the branch, and you can add a file manually. It will be still tracked through a commit that is done automatically when you add a file. This could be a way to do it, but
yeah, but don't you have to download the file and then re-upload the file? Yeah. So sorry, copy and paste I'm using as download file from one branch, upload file to new branch, so that sort of thing, which bad practice. It doesn't get tracked that it came from one file to another. You don't get that history. So wait, other questions. The other question I just remembered that we talked about ages ago, and I'm going to mention now, is the our thoughts on dev branches. I can give my thoughts. I'm not sure we've actually had a conversation about this amongst the four of us. My general thoughts, feelings, and vibes about this, as someone who has a horrible memory, is I tend to use my main branches where my main development is. I don't do pull requests of my other branches into main unless those branches work. So main should be functional, but it tends to be quite dev for me. And then I use tag releases as like, this is an official release. So I use that in order to let people know this is the good bit, this is the clean 100% release bit, or a lot of the things I do, I put on CRAN. So I'm using CRAN as that like external marker of standard rather than using main to be I only have released versions on main. As someone, I've like had things that haven't been released on main, but they have been on dev. And then I've like pushed that to CRAN and all sorts of chaos because I forget to do that final push to main. But usually my projects are just not complicated enough to warrant having a dev and a main, basically. But that's what I do. I don't know. Irene, what do you do? Oh, she's quiet. You've gone away. Have I scared you off?
Did she just get kicked out? She just disappeared. I know.
Just disappeared. Don't know.
I can't comment on that, Christina.
Yeah,
but no, other people do use main as their like the only released versions go on main, which I think is totally fine. Basically, because I work in R primarily, and R has the like niceness of having CRAN where everyone goes to get releases. People are not really looking at my GitHub to get releases from. That the expectation that my main is perfect is relatively low. So kind of depends on what you're doing. Okay. Cool. Would be great.
And Irene's coming back.
Sorry, I got kicked out.
No worries. No worries. Are you all ready for me to take over, or?
Irene, what is your thoughts on the dev versus, because you do the opposite, don't you? You use main and dev, and then
we use main and dev for just a reason to have one branch that is always connected to the package manager, and this is really like what shouldn't be it, but it's just a nomenclature that we have decided at the beginning. But I've seen people that don't use main at all because they don't like the name of main, and they just they change the name of what's the main. Oh god, it's very difficult to explain that, but I'm for being simple as well, so I totally see why you have a workflow like that. It depends on the constraint.
Yeah.
We just have one more question. There's something that seems not to be working, but I got kicked out of the chat, so I can't see.
So what would be the command order of actions if you wanted to or needed to handle a pull request locally? Thinking of a more complex case where you tinker with code. So when you're doing a pull request locally, that's when you're doing the merge. So that's when you have the kind of what Irene showed about the going onto the branch that you want to merge into, and then using the git merge command to merge that in.
And then Asavari is struggling to see the files. That could be because she's either in the wrong location, couldn't it? Like if you've not checked out the branch that you're pulling to, or because this often happens, I think, doesn't it, where you're not getting the changes pulling through, and you need to find out why. I think that's a common issue.
Have you performed a sync from the PSI to your remote? Otherwise, you wouldn't be able to see who got added.
Hi, can you hear me?
Yeah.
Yeah.
Yes, this is Abby. Actually, so I guess Christina accepted my change, which got pulled into the main. And then I didn't see a sync anywhere after that. But then I just refreshed it, and then I saw the 3 files, Vikrant, Irene, and mine, in GitHub, but not in Posit. So I did
Yes.
that everything is up to date, but I don't see it in Posit. I only see it in.
Is it possible because first you need to do this sync fork?
Oh,
I
hang on, you're
actually
not
not
sharing.
sharing
No, I
the
think
screen.
she's
I'm
still-
sorry.
So yeah, you need to do a pull request. So you need to pull down from the remote where everything is onto main. Sorry, I'm about to be jumped on by a cat.
That's cute.
Irene, you have trouble sharing your screen again. At least for me, it's
Oh my god.
like.
But this is a
saying-
great question, Asari, because this is what happens all the time. And then you're like,
Yeah.
why can't I see things? And it's really frustrating. So I'm really glad you raised this one.
Yeah,
Christina, please share.
Pull it down.
But she said that she sees it in depending on which GitHub, because if she sees it on yours, that makes sense. But it also needs to be on the forked.
Correct.
So I think maybe
yeah.
that's what it is.
Yeah. Actually, can you share? Can you share your screen with what you're sharing?
I can try again, but it didn't work. For some reason, it hates me.
Well, no, I was thinking, yeah, I'm
Oh.
very confused why it particularly doesn't like you.
Can
Yeah,
you
yours
see?
isn't working, Irene.
Oh, I'm sorry. It worked for a long time, so it's not so bad. We can
Here,
complain.
I can probably share. I can share.
You might drop off and see if coming back helps it, but no guarantees.
I can,
Just quick idea.
I can try.
Okay. Because I think I have the authority to look at everyone's forks. So at the very least, I can look at the fork. Okay. So.
I think this is one of the most common things of people getting confused when we're just struggling to kind of sync everything back together when you want to.
All right, I'm trying to type as fast as I can. Okay. So this is me looking at everyone's forks. So if I go here, yeah. So The problem is I think that you're probably looking at the PSI/GitHub, because when I look at your repo, there's only your file. There's none of the other additional files. So you need to go back to your repo and sync it, and then those files should be able to appear. The sync button is going to be like right there, but I don't have a fork, so I don't have a sync.
How do I go to my repo? Sorry.
You can go to your repo by honestly going here.
If you're now probably on the PSI Ames Git training page, and
No, it's fine. She can just go here. She can go. So let me just undo the link.
Sure. Otherwise, she could have used the fork thing, because you only see your own fork. Then it takes you there.
You can also always click on your name. If you click on your GitHub name in the top corner here, or like I can click on my version and look at my repositories, it will be everything I've ever like cloned or forked. So for instance, I forked the R tables thing. And actually this is a decent example, because I am 8 commits ahead and 53 commits behind. So I'm going to sync that, and I'll have to discard a bunch of commits, but that's fine. And now I'm all up to date. So you should be able to do something similar.
So when you synced that, Christina, you'd made some changes, 8, and you discarded them, but then it almost brought in the 53 commits that have been made to the repository since you last synced.
Yes, exactly.
And this is specifically because it's a fork, isn't it? Not a branch from
the
repository.
Yep, perfect. You've brought the branches in. You've synced correctly, because now I also see them in your repository.
Thank you.
No worries. Okay. I think it's now time to hand over to Alex for the last little bit of going through some novel things we can do with GitHub if we want. Alex, do you want to maybe do 10 minutes of it, and then I'll do a summary?
Yeah, sure. I'll run through it real quickly. So yeah, no worries. You are through the worst of it. The hardest part lies behind you. So can you see my screen? I guess you can. We're officially in the cooldown phase. So what I'm going to show you is nothing stressful at all. You don't have to wrap your head around how to clone a repository, get all of the code into your POSIT workbench. And none of that will play a role at this point. I'm going to show you how to work with GitHub issues. And I've used myself as a example here. So imagine me. And I personally love dplyr, but I tend to struggle with dplyr's filters because they tend to drop missing values. It just checks if something is true, and if it's anything other than true, could be missing, then it drops that. And I would really love for that to be implemented as one of the filter features. Like there could be an option where you say, okay, include missings, true or false. So what do? R is really this great open source code language. So I'm going to take it to GitHub, and I'll create an issue asking the dplyr team to implement that. So in order to do that, let's take it to the internet. So Google is your friend. The first thing we are going to do is we're going to locate the GitHub repo for dplyr. So you can see this here is a GitHub link. It says, okay, tidyverse, which is the overall structure under which dplyr is managed. So we're going there. And if you're struggling with something, like if you are not sure if something is an issue or not, or if you would like to have it implemented, the first thing you do is you check if somebody else has encountered similar issues. Like, is somebody else looking for something? So you take it to this Issues tab here. This is basically the landing page. This is where all of dplyr is managed. These are the issues. You can see open pull requests. You can see the insights here, for example, looking into the network graph that Irene has showed you. You can also see that it has 57 tags, so that's kind of cool. You see, all of the versions, the stable versions, have been tagged in GitHub, so that is something cool to remember, and that is basically the package code. So we would like to see if somebody on the internet has already opened an issue related to filter and the filter function's behavior with regards to missingness. So I'm seeing all of the open issues here. Currently 55 of them are open and 4,838 are closed. We also see something like the contributing guidelines here. Like if we were to open an issue, then we're being asked to adhere to the guidelines. You can look into that. It basically gives you this structure and code of politeness, how to open an issue and contribute to dplyr. So a lot of packages will have that. Just read through it and make sure to keep all of these things in mind when you open your issues. We, however, are checking if something exists already. So the function we're looking at is filter. And let's just see if something related to filter and missing. Filter is open. What did I do wrong? Okay, nothing. I probably hit the wrong key. So now we're looking for open issues where filter and missing is already mentioned. We can browse through them and see, okay, this one here, for example, option to optionally retain missing values. This sounds promising, right? So currently filter retains true, drops false, and NA, this matches subset. But this user, well, it's Davis Bowen, he would like to request something like retains true and NA, drops false, and this matches the brackets. Huh, that is basically what I'm looking for. So there is no need to open the issue for this, this specific use case. If I am interested in leaving a note there, I can write a comment. Like if you see, we can see that this is an issue that is already being worked on, but if you see that a user or a package author is pretty idle and does not reply to your or the person who has issued this this request does not really reply to this issue, then you might leave a comment like, hey, I'm encountering the same thing here. Same. And you might want to leave a couple of lines of code just for the author to be able to see what you do. So let's say I would like to open an issue in the PSI Aims Git training slides. Let's quickly walk through this, see how it works. I'm giving something a meaningful title. Oh, it's pre-populated. That's cool. Because I worked through this before. So I'm choosing a meaningful title. In my case, I would like to add the option to choose missing value behavior for dplyr filter. I'm not opening something in the dplyr GitHub right now. I'm just showing it in a safe space, which is currently the Git training slides. Imagine this being the dplyr repo. And I'm writing a couple of lines saying, hello team, just be polite, have a conversation with the authors, and describe your problem. And then you can see that this piece here, where I have these 3 little high commas and the R, and 3 little closing high commas, this is basically markdown language. So here I can embed my code. I say, okay, I'm working with dplyr, then my tibble, which is the test data that the author is going to use. This is going to look like this, and the filter dfxyz is what I would like to have. And you see, when I switch from the right to the preview pane, I can see this nicely rendered. I also did that inline code chunk or markdown chunk, where I can see here that this is rendered and looks like code now. So this is really nice. So of course I could add a little bit more text, but once I'm happy with how that issue works, you would like to hit submit new issue, and Christina, as the author of the PSI Aims Git training slides, would be informed that there is a pending issue in her repository. And she could then reply to me. Yeah, I'm not going to do this here, but in principle, whenever you are working with our packages and you encounter something that is not working the way you would expect it to do, or it might work, but it really took you a very long time to figure out how, because you were missing some basic details in the package documentation, please take it to GitHub and use the issue function. First of all, check if an issue related to something similar to your problem already exists. And if it does, leave a note for the author, like, hey, same here. I'm running this on our version, whatever. Attach a session info, that always helps. And if it's related to a couple of lines of code, then provide a reproducible example. Yeah, otherwise you open a new issue, kind of going in the same direction. Make sure to describe your issue thoroughly, add a couple of lines of example, and then submit it newly. If you are missing something, if you are encountering a bug, it does not mean that you can never ever use the package in the future. The author might just not have considered your specific use case. So please feel free to use the issues as much as possible. It is a great way to have a conversation with package authors and hopefully get your issues resolved. Christina, did I overstretch my 10 minutes?
No, you were exactly 10 minutes.
Oh, I love that. I'll stop sharing them.
Perfect.
Would you like to do the rest?
Yeah, I'm gonna just close this out. I guess we actually probably have a little extra time, but I want to make sure that people are not overly done. So I'm going to just do a quick summary of today and talk through kind of what we chatted about, what we did, go back in time to almost 3.5 hours ago. So let's just have a quick chat, and then you guys can be free. But thank you for everyone for joining the session today and asking great questions and participating. That always makes doing a workshop so much better. But what did we talk about today? So you'll recall back to yonder year. We talked about the difference between Git and GitHub and helping that and using that difference to help us understand the difference between what's happening locally on our computer or our Posit Cloud session or wherever you happen to be working versus what's happening on remote, which is today it was GitHub, but it can be whatever. We also talked a bit about committing and the idea of tagging things and that you can tag releases or when you've submitted a project for a final SAC or what have you. We also talked a bit about branching and how branching can help us understand. Basically, branching will help us do updates without having to mess with everything else. This can be particularly helpful when you're working in groups of people because then you can do updates on your stuff, and even if it doesn't fully run, you're not going to break stuff for everybody else. Then we also talked a little bit about merging and dealing with merge conflicts. Finally, we talked about remotes, the idea that there's something on, in this case, GitHub versus on your computer. And then we talked about forking at the very end. once we talked about forking, we basically immediately switched over to have you guys practice. So you guys made forks and you guys did a great job. It looks like most of you were able to do the forks. I get to see the number of forks that were made, and it's a reasonably high number. So good job, everyone. Give yourself a round of applause. I know doing things like this is kind of big and scary, and there's a lot of new lingo, but you did great. Then we created a project in RStudio, and we connected our RStudio to GitHub using a PAT token. The one thing we didn't mention about PAT tokens, but is probably worth mentioning, or at least I don't remember mentioning it, is they can expire. So by default, I think the expiatory is 30 days, I want to say, and I don't think we changed anything, so they may or may not expire. It's fine. It's just a way of, it's kind of like you probably at work have a company password that expires every 2 months or whatever your company's policy is, and you have to constantly be making new ones. It's like that, except for you don't have to make up a new one. You just go and rerun that code again to open up the thing that makes a PAT token, copy that again, and put it back in. So it's pretty easy to do. You'll maybe have to do it once a month or a little bit less frequently than that, depending on how long it's set up, but they can expire. And so we've connected that up. We've taught you how to connect it, which you may do again at some point in your life. Then we also did a little bit of committing in RStudio. We looked at everything in that little Git pane in the top right corner, looking at the history and branching and all sorts, pulling and pushing. Then we also talked a bit about staging, the idea about what staging. The working directory is where you are, it's where your head is, right? So you can't see files that are not in your current working directory. They can't see the files if they're not in the branch that you're on with the head. Then finally, we had talked a little bit about local repositories versus what's on the remote. We did a pull request, we did some merge conflicts, and we also talked about kind of authoring issues and all sorts of things like that. And looking at issues, which is one of the biggest things that you'll use GitHub for, is looking at the issues for people if you don't end up doing open source development yourself. The other thing we want to leave you with is just some additional resources. We will send you this. Sorry if you can hear my cat. We will send you these slides. They will be updated on the Git test training repo. They will be put up there on the Git training repo, which you have all forked. So you will hit the sync button, and then the slides will magically appear in your local repository, or you can go back to the original PSI one and pull the slides from there. So I can recommend all of these things. The Happy Git by Jenny Bryant is really quite a nice one for setting up things with R. It's very R specific. So if you ever feel like you need a written resource that's not us in the future, that is a good place to go.